Hypothesis testing. In everyday life, we often have to make decisions based on incomplete information. This may be decisions that are important to us, such as: will I improve my biology grade if I spend more time studying vocabulary? Or should I become chemistry major to increase my chances of getting into med school? This section is about the use of hypothesis testing to help us with this decision. Hypothesis testing is a kind of statistics inference that involves asking a question, collecting data, and then examining what the data tells us about how to proceed. In a formal hypothesis test, hypotheses are always statements about the population. The hypothesis might involve statements about the average values, means of some variable in the population. So, it is an educated guess about something in the world around you, either by experiment or observation. For example, a new medicine we think might work, a better way to administer, test, a possible location of new species. Come to developing null and alternative hypotheses. In statistical hypothesis testing, there are always two hypotheses. There is an initially research hypothesis of which truth is unknown. For example, a researcher thinks that if knee surgery patients goes to physical therapy twice a week instead of 3 times, their recovery period will be longer. And average recovery times for knee surgery patient is 8.2 weeks. The hypothesis statement in the question is that the researcher believes the average recovery times is more than 8.2 weeks. So, it can be written in mathematical terms as H1 mu greater than 8.2. Next, we need to state null hypothesis. That's all. What will happen if the researcher is wrong? In the above example, if the researcher is wrong, then the recovery time is less than or equal to 8.2 weeks. In math, that is H0 mu less than equal to 8.2. The researcher hypothesis proposed by researcher is called researcher hypothesis and give the symbol of H1. The hypothesis to be tested is called the null hypothesis and give the symbol of H0. The null hypothesis states that the average recovery time is less than 8.2. Now, to prove our research hypothesis, we had to disprove null hypothesis. So, null hypothesis, a statement So definition of null hypothesis: a statement about the value of a population parameter developed for the purpose of testing numerical evidence. Alternative hypothesis, symbol HA or H1, a statement that is accepted if the sample data provide sufficient evidence that the null hypothesis is false. Deciding whether to reject the null hypothesis. The alternative hypothesis can be supported only by rejecting the null hypothesis. To reject the null hypothesis means to find a large enough difference between your sample mean and the hypothesized mean null hypothesis. If the difference is very small, we don't. In each hypothesis test, we have to decide in advance what the magnitude of the difference must be to allow us to reject the null hypothesis. If we fail to find a large enough difference to reject, then we have to accept null hypothesis. The four possible outcomes in hypothesis testing: null hypothesis, H0 is true. Researcher does not reject correct decision if researcher rejects type 1 error. If null hypothesis is false, researcher does not reject, that is type 2 error, mean researcher accept null hypothesis, but null hypothesis is false. Researcher reject, that is correct. Null hypothesis is false, so researcher reject the null hypothesis. We can get from here type 1 error. Type 1 error occurs when the null hypothesis is rejected when it is actually true. This one our type 1 error. The probability of making a type 1 error is denoted by alpha, which is the significance level set by the researcher. Type 1 error example: in a medical test designed to diagnose a disease, a type 1 error would occur if the test incorrectly indicates that a person has disease when they don't actually have it. I mean, it is reject the null hypothesis. Type 2 error, false negative. A type 2 error occurs when the null hypothesis is not rejected when it is actually false. You can see this one our type 2 error. Researcher does not reject, but null hypothesis is false. This means failing to detect an effect or difference when one actually exists. This probability of making a type 2 error is denoted by beta. Type 2 error example: in the same medical test, a type 2 error would occur if the test incorrectly indicates that a person does not have the disease when they actually have it. So fails to reject the null hypothesis. Type of hypothesis testing: one tail and two tail hypothesis testing. One tail test, unidirectional hypothesis, where the area of projection is on only one side of the sampling distribution. It determines whether a particular population parameter is larger or smaller than the predefined parameter. It uses one single critical value to test the data. null hypothesis, mu represent a parameter and mu 0 is the specific value. Alternative hypothesis for a right tail, that is h1, so mu greater than mu 0. Mu 0 is your null hypothesis population mean. For a left tail test, h1, that is mu less than mu 0, mean less than population, null hypothesis population mean. Left tail test, for a left tail test, h1, there mu less than mu 0. Example, effect of participants of student in coding competition on their fear level. H0 mean null hypothesis, there is no important effect of student is coding competition on their fear level. The main intention is to check the decrease the fear level when student participate in a coding competition. Mean the fear level less than or greater than, that is our one tail test. Two tail test. Two tail test is also called non-directional hypothesis for checking whether the sample is greater or less than a range of values. We use the two tail. It is used for null hypothesis testing where mu represent parameter and mu 0 is the specific value. Alternative hypothesis, mu not equal to mu 0, mean your population mean for null hypothesis. Alternative hypothesis h1 where mu not equal to mu 0. Example, effect of new bill pass on the loan of farmers. Here H0, there no significant effect of the new bill pass on loan of farmers, but new bill passes can affect in both way, either increase or decrease the loan of farmer. So that is a two tail test. The table provides template sentence for common statistical test, like statistical test, two sample t-test or one way ANOVA with groups. Null hypothesis, the main dependent variable does not differ between group 1 and group 2 in the population. So mu1 equal to mu2. Alternative hypothesis, that time mu1 not equal to mu2. Next, one way ANOVA with three groups. So null hypothesis meant dependent variable does not differ between mu1, group 1, group 2 and group 3 mean. In the population mean mu1, mu2 and mu3. So mean of the group 1 equal to mean of group 2, mean of group 3. But alternative hypothesis, the mean dependent variable of group 1 and group 2 and group 3 are not equal. Pearson correlation. Null hypothesis, there is no correlation between independent variable and dependent variable in the population. So p value equal to 0. there is alternative hypothesis, there is correlation between independent variable and dependent variable in the population. So phi not equal to 0. Simple linear regression, there is no relationship between independent variable and dependent variable in the population. Beta 1 equal to 0. An alternative hypothesis, that time beta 1 not equal to 0. Two proportion Z test, dependent variable expressed as a proportion does not differ between group 1 and group 2 in the population, that is null hypothesis. And alternative hypothesis, dependent variable expressed as a proportion differ between group 1 and group 2. So P1 not equal to P2. This is our hypothesis testing. We will discuss in details next video the standard normal distribution, also called Z distribution. This is the very important video.